Hello, in this video, I will go through the work that Dr. Tikabi and myself, Manar, conducted to design a hybrid policy engineering framework for ABAC, which is attribute-based access control. This is a roadmap of this video. I will start with a very brief introduction of ABAC. So what is ABAC? It is a kind of access control models. With this model, authorization decisions are made or taken on the basis of attributes of the subject, requested resources, and the environment condition. So for each request submitted by the subject, the attributes of all involved elements will be checked against predefined rules. If the values of these attributes meet or satisfy the definition of the rule, then the request will be granted, else it will be denied. So the fact that ABAC is based on the notion of attributes provide a high flexibility that is actually needed by today's highly dynamic business environment. However, coming up with the rules themselves still pose a costly development effort. So for the cost reduction, there are two main lines of research: the top-down engineering approach and the alternative approach is bottom-up engineering approach. With the top-down, the focus is to automate the transition from organizational policy in its natural language form to machine-readable form. And as you can see here, there are a couple of examples of studies that show the potential of this approach, like identifying ABAC sentences from project requirement documents, extracting the subject and object element, and also extracting the attributes on these element. However, the limitations of the underlying approach, which are normally natural language processing and machine learning, data acquisition as well, pose a challenge in the face of the advancement of this approach, I mean the top-down. For the alternative approach, which is the bottom-up, the focus is to automate the transition from whatever access control system is currently in use to ABAC. This approach uses the attributes of different elements that currently exist in the system, as well as the information related to the currently used access control. An obvious limitation with the bottom-up is that it completely ignores the organizational policy. It also uses attributes that are not collected or designed with ABAC model in mind. This will definitely affect the quality of the produced rules. So we sought to combine the benefits of both approaches. In particular, we designed a hybrid policy engineering framework that combines element of the top-down and bottom-up policy engineering approaches. We also designed a similarity matrix to enable this combination. This is an overall view of our system. As an input, it takes the natural language policy, organizational policy in its natural language form. It takes the attributes of different elements in the system and attribute data, and it takes as input the log of access request. It consists of two main components, the top-down and the bottom-up component. For the top-down component, we analyze the policy and we analyze the policy, and we also compare the given attribute against the policy in order to select among all the given attributes those that are actually relevant to the expression of rules. Once we identify the irrelevant set of attributes, we provide them as an input to the bottom-up minor. We call it minor. In order to produce the first set of rules, we then also refer to the organizational policy to improve the produced rule. Finally, we produce the ABAC rules using the hybrid approach. Okay, now the first step of our framework is the pre-processing step. And this step, we convert the key value pair to the actual meaning. Usually the key value are stored in a coded format. We convert them to their actual meaning, as you can see in this example. This is a very essential step in order to enable the next step, which is the selection of relevant attribute. Next, we select the set of relevant attribute. Now the question is, what are the relevant attributes to the expression of ABAC rule? Now, if we look back to the definition of ABAC rule, we can tell that the ABAC rule consists of attribute expression, which is a relation between an attribute and its value, and condition expression, which is a relation between two attributes. In order to identify the attributes that belong to the first group, which is attribute expression, we analyze organizational policy provided by the as an input, chunk each sentence and examine its similarity to the attribute values produced by the first module. If the pair is similar, then we consider the attribute as a relevant attribute. In order to identify those that can be part of condition expression, we compare user and resource attributes and collect those that have values that came from the same domain, since it can be used to express conditions. Now, once we have the set of relevant attributes, we provide it to the miner as well as the access log to produce the first set of rules, as you can see. So the miner will produce rules. Here's an example of a rule produced by our experiment. Now the question is, to which sentence this rule belongs? I mean, which of our authorization requirement this sentence implement? In order to answer this question, we have our mapping module. The mapping module will map each produced rule to the sentence that it likely implements. In order to enable this mapping, we designed a similarity matrix. The formality of this matrix is discussed in details in the paper. So here's an example of the rule and the mapped sentence. The mapping makes a lot of sense. Still, the rule doesn't capture the sentence perfectly, and therefore we have our fifth component, which is the refine mind rules component. Here we compare the rule against the sentence that it likely implements and improve the rule accordingly. This is a rule-based module based on semantic rule labeler and our findings in earlier studies in how to extract the attributes of subject and object. Now, in order to experiment with the proposed framework, we require data that consists of policy document, attribute of different entities, attribute data, and access log. We constructed a data, since there is no readily available data that contains all these elements. We used the IPM course registration policy documents that has been frequently used in similar research in this area. We break down the sentences in this data set to attributes. We enrich the attribute with additional set to simulate a real case scenario where the attribute that we start with doesn't only capture the rules, but contains additional irrelevant attributes. We initialize the attribute to create instances of the subjects and objects and the system. We have this number of distinct values in the system. In order to produce the rule, we refer to Shaw's log generation algorithm discussed in the paper. We experimented with the hybrid framework as we discussed earlier. The experiment produced set of rules. In order to examine the quality of the produced rules, we use Jacquard's similarity to capture the similarity between produced rules and the grounded truth. The value of the similarity score falls in the range of 0 and 1. 0 indicates completely different rules, and 1 indicates similar rules. Our approach, the average of similarity scores of rules produced by our approach was 0.7. And now, in order to understand the significance of this number, we compared the similarity of rules produced by the bottom-up miner with the grounded truth, and it was 0.4. So here you can tell that there is a significant improvement using our approach. So in this work, we designed a hybrid policy engineering framework. We also designed a similarity matrix in order to enable the combination of the bottom-up and top-down. We evaluate our approach and the results show a significant improvement using the hybrid framework. Thank you all. This is Manar again. If you have any question, please feel free to email me. My email is in the first slide and also in the paper. Thank you all.